detailed evaluation of the immune system, we widely use flow cytometry. Flow cytometry for to differentiate peripheral blood lymphocyte subsets, also to differentiate disease-specific molecular defects. For example, we use monoclonal antibody against CD4, DOC8, LRBA, or HLA-DR, and to see the expression there, it means that the disease is not there. If you not see if you not detect the expression of these molecules, you then think about the disease and go to the genetic defects about these molecules. So for humoral immunity, we usually do the specific antibody responses, IgG subgroups, and disease-specific analysis against our BTK expression here. For complement, we can test each protein either by radial immune diffusion or ELISA tests, and we see if there is what is the level of protein. For cellular immunity, I told you before that to see the peripheral blood lymphocyte subsets and other subsets in details. For example, the memory subsets, naive subsets, and in details we can identify the peripheral blood lymphocytes in these with the flow cytometry. And in vitro lymphoproliferative responses also against some antigens is very important for determining the functions of these cells. And also disease-specific analysis is very important. For phagocytes, we can proceed with chemotaxis or adhesion molecule expressions like that one. The defect is in CD18, is a chain of the integrin, is a common alpha chain of the integrin. And we also test about plastic phagocytosis and bactericidal by fluorodanine, which is again in flow cytometry is helping us. And very quick response, very quickly at the same day, you can get the results of the peripheral blood subsets or subspecial disease-specific analysis or bactericidal killing test, which is very important and effective and relevant way of laboratory evaluation. Radiology is also helping us, whether the systemic shadow, to see the systemic shadow, or the patients with recurrent pneumonias and bronchiectasia, what is going on with the organ systems, respiratory systems, and other systems, also the diagnosis and follow-up. We have been using radiology. And genetic diagnosis is very important at the moment. For we have to be sure about the genetic diagnosis to perform the treatment, because there are many different biologic agents at the moment, and the enzyme replacements is, as you know, that the technology is very fast. So for genetic counseling and for prognosis and for newborn sequencing even, we need some genetic tools. And in a test study that performed one of our students before, type of inheritance according to the genetics mutation, as we told at the beginning, is very the big part of the genetics are autosomal recessive, has autosomal recessive inheritance. And also the treatment is important because gene therapy is first successfully performed in 2000, and coming to the 2024, we are talking about gene editing at the moment. So, as you know, that Nobel Prize has been given to have you heard about this endonucleases, Cas9 endonucleases for giving us the opportunity for gene editing. And for the natural course of split, you see here, split is a very severe disease. There is no sign at birth. There is an asymptomatic period with a couple of weeks or months, and the symptoms begin early after this period. And infections are growth retardation are the major symptoms, like plasmodiasis and live vaccine problems and skin viral diseases and respiratory diseases. Then the patients have organ failures and died about 1 year of age. So it's a very severe and very poor prognosis disease. And you have to know the diagnostic symptoms and findings and skin, which are common. You can see these are the major symptoms and findings and skin. So, how do we overcome, how do we treat these patients? There's a curative treatment in all SCID cases. SCID is not a single disease. There are more than 20 different genes responsible for SCID, severe combined immunodeficiencies. In all, the T cells, there is a problem in T cell development. B cells can be developed or not, NK cells can be developed or not, and the phenotype, immunologic phenotype, appears according to these findings. And different genes leads to different immunological phenotypes. In Turkey, RAG defects and Artemis defects are the major genes behind SCID patients. But in Western countries, mostly in gamma chain defects are the major reason. We have some good papers, very helpful to get the diagnosis when we need to. For example, you can see this combined immunodeficiency. This is an example. For example, combined T and B cell immunodeficiencies. If lymphopenia is here, then the patient is SCID. If lymphopenia is not so significant, then you have a combined immunodeficiency. And you see that by this algorithm you can easily think about it, not easily, but you can think about the genetic and the exact disease of the patient. So early diagnosis is mandatory. You need suspicion, we need suspicion, we need awareness, we need follow-up, but they are not enough. We also need screening, newborn screening. And newborn screening is not nationwide still in Turkey and in many countries of Europe, but in the United States is mandatory and nationwide procedure. But also Europe is improving. And in Turkey, we conducted the first preliminary prospective study for newborn screening, and we performed it by blood records. You know that blood punctures, heel punctures, and get blood to gut records, dry blood spots. We use the same dry blood spots and get the DNA extraction and then track amplification to see if thymopoiesis is working or not, functioning or not, thymus. By track amplification. Track is the T-cell receptor excision circle, is the T-cell receptor copies could be identified by this laboratory test. So you can change the natural history of SCID via newborn screening. This is the first child transplanted in the United States after diagnosed with newborn screening. And this is the first two childs diagnosed in Turkey by prospective trace study that I mentioned before, just before today. And the first one has ATA deficiency, and the second one is RAC1 deficiency. This patient got gene therapy in Italy. Intelletto Milano is a major center for gene therapy for many years. And the second got the bone marrow transplantation from her sibling in our unit, bone marrow transplantation unit. So they're both doing well and growing well. What do you think? Shall we give a break?
Yes, Professor.
For 10 minutes? Okay. Let's get at a 1:15.